box for an individual mobile phone is 13 centimeters long, 8 centimeters wide and 6 centimeters high as shown. Find the volume for the individual mobile box. So volume is length by width by height. Volume is going to be 13 by 8 by 6, and this should be measured in centimeters cubed, so it's going to be 13 by 8 by 6, and you get 624 centimeters cubed. All right. Next one. These are the individual mobile phones will be shipped by large rectangular boxes. Below are diagrams and nets of two large boxes that could be used, box A and box B. Show that box A and box B have the same volume. Okay, well they both have, we both got to get the length by the width by the height. So multiply all three dimensions by each other. One of them's 32. So one of them's 32 multiplied by 30 multiplied by 78, and the other one is 40 times 48 times 39. It can be in any order you want. I'm trying to prove these are the same. So 30 by 32 by 78 is 74,880 centimeters cubed, and then the other one 40 by 48 by 39 is also 74,880 centimeters cubed. Okay. Next part of this question. What is the largest number of individual mobile phones that will fit into each large box? Well, we're assuming so what's it? 8, 13, 8 and 6. So 13, 8 and 6. So you can do it two ways. I'm just making sure it fits in evenly. See 78. When you divide 78 by 13, you get 6. When you divide 32 by 8, you get 4. And finally, when you divide 30 divided by 6 is 5. And basically 6 by 4 by 5 is 120 different small boxes will fit in the big box. It means they fit in equally, okay? And look at this one. If I divide this one by 8, it goes in 5 times. If I divide this one by 13, it goes 3 times. And if I divide this one by 6, it goes 8 times. And 8 by 5 by 3 is also 120. So it divides in properly. That's the main thing you need to know. All the boxes fit in snugly. So what you can say is the area of one box divided by the area of the original box, which is 624. And you're going to bet that this is also 120. Okay, so there's two ways of doing it. I like the other way because it guarantees that the boxes fit in properly, while this way doesn't. Okay. Find the surface area of each large box. Let's go back to our original diagram here, right? So what we're going to do is going to have to find out the surface area of each one. So we let's bring this down slightly. Okay, now look at this. Surface area is different, all right? So this is 32 times 30. So we're going to do 32 times 30. And we're going to find out it's 960. And this one is also 960. Then we got so this one's 78. See this one here? This one's 78 and 32. So 78 multiplied by 32 is 2,496. 2,496. So this one's also 2,496. The next one's 30 times 78. So 30 times 78 is 2,340. 2,340, all right? So essentially what you're doing is 32 times 78. You're doing 30 times 78. And then you're also doing 30 times 32. Okay, and you're going to put all these, so what's it? 2496. And then you're also going to get 2340. And you're also going to get a, what's a 640? Or sorry, 960. Now you got to remember, this is only one side. We got to multiply all of these by 2. So this only counts for half the area. We got to multiply by 2 because there's 2 of them each time. Remember, there's 2 230s, there's 2 2496s, and there's 2 960s. Okay, so we're going to have to multiply or add them together and multiply by 2, or you can multiply each one by 2 and then add them together, whichever one you want. So I'm going to add these together to get 5796. Then I'm going to multiply that by 2. I'm going to get 11,592 centimeters cubed. Okay, now I'm going to work on box B. So box B, we're going to have 40 times 48. And 40 times 48 is 1920. Okay. 40 times 48, so that's 1920, and this one's also 1920. Then we're going to have 40 times 39. So 40 times 39. And that's 1560. And we're going to multiply, so there's 2 1560s, that's 12560, 1560. Next we're going to have, what's it, 39, I believe it's 39 times 48, 39 times 48 is the next one. 39 by 48. And that's 1872. So go back here, this is your 1872, and that's your 1872 as well. They usually have a gap of 1 box in between them, okay, or 1 rectangle in between them. So we're going to add these together and then multiply by 2. Now just because the boxes are the same volume doesn't mean it takes the same amount of cardboard to make them. They can have the same volume but different surface areas. So that's the interesting thing about area and volume. So you can have the same volume but different surface areas. So this is 5352. Multiply this by 2. 5352 and multiply by 2, and we get 10,704 centimeters cubed. So we have a different surface area for both of the boxes. Okay, the large boxes are made from cardboard. The cardboard costs this much per meter squared, and we are currently in centimeters squared. Oh great, this is going to be great fun. Find the cost that uses the least amount of cardboard. Alright, let's think about what a meter squared is. A meter squared is 1 meter multiplied by 1 meter. And 1 meter squared is effectively 100 centimeters multiplied by 100 centimeters. Okay, so it's an area of 100 centimeters multiplied by 100 centimeters. So 100 multiplied by 100 is 10,000 centimeters. So 10,000 centimeters cubed, or sorry, centimeters squared equals 67 cents. We're first going to have to figure out what 11592 centimeters squared is, and then we're also going to have to figure out what 10,704 is. Well, actually, we only have to find the cost of the box that uses the least amount of cardboard, so we actually only have to find out the cost of the 10,704 one. So we're going to divide both sides by 1,000, so 67 divided by 10,000, excuse me. All right, so that's 67 over a million. All right, so 1 centimeter squared costs 67 over a million. Okay, now we're going to multiply that. So we divide by 10,000 and then we multiply by 10,704. So multiply your answer by 10,704 and we get 0.717. So it's 717 or 0.72, 72 cent for the box. An average of 140 large boxes is produced each month. Find the saving per annum if you choose to make the box that takes the least amount of cardboard. Okay. Well, as it turns out, I was going to need to know how much the more expensive one is as well, which was my initial instinct earlier on. So I'm going to have to find out how much 11,592 centimeters cubed would be. So I'm just going to go back a step. I'm going to divide this by 10,704. That tells me the cost of 1 centimeters cubed. Now I'm going to multiply by 11,592 here, equals 77.66 cents. So 77 equals 0.777, which is 0.78 cent. Okay. 140 large boxes are produced each month. So 140 can get multiplied by 78 cents for the larger box, or 140 can get multiplied by 72 cents for the cheaper box. So you're saving 6 cents a box roughly. So that's 109 or €1.09. Let's do 109.2 cents. And then this one is 100.8 cents. Now, all that calculation just to take the two of these away from each other. 109.2 take away 100.8, and you save 8.4 cents per month. There you go. Efficiency, huh? Let's move on. Okay. So I just want to multiply that out again. Oh, sorry guys, I made a mistake there. Definitely made a mistake. That's 109.2 euro. My fault. Euro. So it's actually 8.4 euro. I knew something was up. €8.40 per, yeah. Sorry guys, my bad. I had it as 2 decimal places, that means it's in euro, not cent. Now this is actually 4b, question 4b, so I did question 2, now I'm doing 4b. Now remember, you gotta find the angle SOP. Now they're standing on the same arc, so if you look at this one here, the green one, this green arc here is standing on S and P and the circle itself, and then you also need the S to O to P is also standing on the same arc. So you can see that both angles are actually standing on the same arc. This means both angles are the same. So sorry. I'm actually looking at SQP there. SQP is 32 because they're standing on the same arc. Now, another thing to note is that when you look at SOP, which I will mark now in a second, when you're looking at SOP, guys, which is the question 1, you can see the way it hits the center of the circle, but still standing on SP. So it means it's double 32 because it's not on the circle, it's at the center of the circle. So that means it'll be double 64 degrees. Okay. Now, 4b part 3. A, B, C, and D are points on a circle as shown below. AC and BD are diameters of the circle. Prove that ABCD is a rectangle. Alright, this should be easy enough. AC and BD are AC and BD shown ABC. Okay, so first thing to know is that AC and BD intersect at the center of the circle. Intersect at the center of the circle. Okay, and then we're going to have angle 1, angle 2, angle 3, angle 4. So this implies that we'll call this O as the center. So it implies that BO equals AO equals CO equals DO. Okay, I think I'm going to go for a bit of SAS here. Okay, so I want to prove that the blue triangle is equal to the green triangle first. Okay, so I'm going to try and prove that blue equals green. Okay, so what we're going to go for is angle 1 equals angle 3, reason being is vertically opposite. Then I'm going to say that OB equals OC, reason being both radii, because they're both radiuses. And then I'm going to say that OA equals OD. Once again, both radii. Now get what I have here. I have two sides and the angle in between. So I have congruent by SAS. Triangle ABOA and triangle DOC are congruent. And then hence BA equals CD. Okay, now the next thing we can say is that we'll call this big angle here angle 5. We can call this other one angle 6. Okay, now I'm going to also prove that the triangle, we can also say likewise triangle BOC, and BOC is the pink triangle, and that's equal to the blue triangle, which is AOD. Likewise, BOC and triangle AOD are equal, are congruent, sorry. Hence, this means that BC is the same length as AD. Okay, so the next thing we're going to say is that if you look at the top, angle 6 is an angle in a semicircle, and angle 5 is an angle in a semicircle. What I mean by an angle in a semicircle is that it's opposite the diameter. Okay, so we can say is angle 5 and angle 6 are 90 degrees because they're angles in a semicircle. So angle 5 and angle 6 are 90 degrees because they are angles in a semicircle. I'd say opposite the diameter just to really spell that home. Okay, and then we can say that angle 7 and angle 8. So we can say therefore angle 7 plus angle 8 has to add to 180 degrees because A, B, C, D is a cyclic quadrilateral. Does anybody remember what a cyclic quadrilateral is? In a cyclic quadrilateral, what you have is you have 4 corners or vertices that are on a circle, and all 4 angles have to add up to 360, and also opposite angles like 7 and 8 have to be worth the same amount. Hence, angle 7 equals angle 8. Hence, angle 7 and angle 8 equal 90 degrees. So, opposite lengths are equal. Opposite lengths are equal, and all 4 angles are 90 degrees. Hence, it's a rectangle. Okay, now let's move on. Really quickly with the construction, I suppose. I'll just do this construction for you really quickly. 6. 1, 2, 3, 4, 5, 6. ABC is 90, so that's A, that's B. And then we're going to flick that up at 90 degrees, like so. For B. B, we don't know the length of B, so I'm just going to make B fairly long. Okay. Next thing is we're going to get our compass, like so. We know that A to C is 10, so I'm going to make this compass of width 10 if I can. Just about, I hope. Am I able to make this work 10? Alright. Oh, that's annoying. My lengths are too long to make this work, so just give me a second. I have to do this again. Fun times. The limitations of my software sometimes. Okay, let's make this back into 6. There we are there. We have AB, which is grand. So I have a length of AB is 6. Now I have to get a length of 10 using my my compass. All right, that's great. Now I start off at A. I make an arc like so, and see where it hits the line. That means that's C. And the length from A to C has to be 10. Oh, no. The length of AC has to be 10. So, AC is 10, AB is 6, and this is 90 degrees. Great. Measure CAB. So I'll get my compass out, like so. I'm going to try and measure, what's it, CAB. So the central letter is important. I'd say about 51, 52 degrees, about 51 degrees, I'd say. Okay. Now, question 7. We got this diagram here. We're going to have to do some work on it. Okay. So, let's find out the point of AC. A is 0, 5. C is 4, 0. And B is minus 4, 0. Find the total length of the metal bars needed to make this part of the swing. Which parts are A, B, and AC? I need to find out what A, B, and AC are. So, I suppose I could do Protagonist Theorem to be really fast about this. This is a length of 4, and this one's a length of 5. So I can use Protagonist Theorem to find the distance, or you could use the distance formula for coordinate geometry. You could use this formula here as well. x2 minus x1 squared plus y2 minus y1 squared. I'm just interested in doing this a bit faster, so I'm going to get x squared equals 5 squared plus 4 squared. X squared equals square root of 41, I believe. 25 square root of 4. X squared equals 41. X equals the square root of 41. Now, as it turns out, AC is the same. So AC equals AB. So it's going to be 2 times the square root of 41. You put that into the calculator, you get 12.8. I think is it in centimeters? It's in meters, so 12.8 meters. Okay, good job. Now, let's move on to the next part. Find the slope of AB and AC. Well, I could do the slope formula, but it's pretty much done for me. It goes 4 across 5 up. So the slope of AB is rise over run, which is 5 over 4. Okay, so rise over run is 5 over 4. Slope of AC, start off at A, go down to C, is down 5 across 4. And that's a slope of minus 5 over 4. You could always do the slope formula, as I said, and use the 2 points. But I'm getting a bit lazy this time of year. Is AB perpendicular to AC? Well, when you multiply them by each other, you should get an answer of minus 1. And if we're looking back at the angle here, this doesn't really make a 90-degree angle. If you look at it really closely, it's not 90 degrees, okay? So we got to figure that out. So it's going to be 4 over 5 multiplied by minus 5 over 4, which is minus 25 over 16. The answer is no, as m1 multiplied by m2 does not equal minus 1. Or you can say product of slopes does not equal minus 1. Not equal minus 1. Happy days. Next one. This is a trigonometry question, but look, we'll go for it anyway. 5 over 4. Tan x is 5 over 4. Tan inverse shift. Tan inverse 5 over 4. 51 degrees. Okay. Good job. In order to increase the height of the swing, it is decided to increase x by 20%. Which one's x? You want to increase the angle by 20%. Find the height of the new swing, but you're keeping AB the same. Okay, what is AB? AB is root 41. We have AB as root 41. That's set in stone. So we're going to increase 51%, 51.34. I'd say 51.34 degrees is the answer it's looking for. We're going to increase that by 20%. So multiply by 120. So 61.6. Okay. So 51.34 degrees multiplied by 120% equals 61.6. The new angle is 61.6. 61.6 degrees. You keep the root 41 the same, but wants the new height, which is h. Okay, so let's do, you want the opposite using the hypotenuse. So it's going to be sine 61.6 equals opposite, which is obviously is actually the height as it turns out, divided by the hypotenuse, which is root 41. The height therefore equals root 41 times sine 61.6. 61.61, the hell with it. Let's do the two decimal places. So root 41 multiplied by sin 61.61 and 5.63, correct to one decimal place, 5.6. Okay, good. So that is question 6, 7, 4, 2. So 2, 4, 6, 7 so far, okay? 2, 4, 6, 7, 8. Find the slope. To find the slope of this, you can either find 2 points on the graph, or you can try and find 2 points on the graph and then use the slope formula, or you can use y equals mx plus c. And mx plus c is generally the way I do it. Get the 3y on its own, so bring the 6 and the x over the other side, so we get minus 3y equals minus x plus 6. Multiply both sides by negative. 3y equals x minus 6. Divide both sides by 3. Y equals x over 3, and then 6 divided by 3 is 2. This means that y equals 1/3 x minus 2. It means it crosses the y-axis at 0 minus 2, and because the c value is minus 2, and the m value is 1/3. Show that the point 1 minus 2 is not on the line L. Well, if it's not on the line L, when I sub in the x and the y value, it should not balance. So 1 for x minus 2 for y. It's going to be 1 plus 6 minus 6 equals to 0. 1 does not equal 0. It's show that it's not aligned. 1 minus 2 is not on the line. Okay. Happy days. That's question 8. The line K passes through 1 minus 2 and is parallel to the line L. This means it also has a slope of 1/3. Find the equation of K. So y minus y1 equals n into x minus x1. We just need what's that word? We need 1 point that's on the line. We're told that x 1 minus 2 is on that line, so it's going to be y minus 2, which is y plus 2, and then it's going to be x take away 1. Replace in m equals 1/3. Multiply the left by 3, so it's going to be 3y plus 6. Multiply the right, it's x minus 1. Move both things to the left, so it's minus x plus 3y plus 6 plus 1 equals 0. Minus x plus 3y plus 7 equals 0. Multiply both sides by minus. X minus 3y minus 7 equals 0. And we're done. Okay, question 8. Now we're on to question 9. Prove that MNP and QRP are similar. So MNP, which is, we'll call it angle 1, is equal to PRQ, which is angle 2. Okay, so we have triangle MNP and triangle QRP. Okay, angle 1 equals angle 2, it's given. Angle 3 equals angle 4 because they're vertically opposite. therefore angle 5 will equal, or angle 6 will equal angle 5 as it turns out, because I wrote it that way. So angle 6 equals angle 5. It's third angle in a triangle. Hence, both triangles are similar. All three angles are the same. They're similar when all the angles are the same size. So it's the same size, but it could be different lengths. Is NM parallel to QR? Yes. Because angle 1 equals angle 2 and angle 5 equals angle 6, it makes them alternate angles. Yes. As angle 3 equals angle 4 makes them alternate. And angle 6 will equal angle 5 makes them alternate. Alternate angles need parallel lines. To exist. Okay, given mn equals 6, mp equals 4, so mn is 6, m to n is 6, n to p is 4. What else do we have? Q to p is 9. And finally, p to r is 10. P to R is 10. Now guys, what I always tell you about these ones is look at them as two separate triangles. Okay, so I'm going to draw a large triangle here. I'm just going to color code them for a second. So it's going to be 9, 10. This is going to be your red angle, your green angle, and your blue angle. Okay, then we're going to put the small triangle on top. And we're going to have, what's it? So we don't know Q to R. So that's P, Q, R. And this is P. And this is N, M. Now, which ones are corresponding sides? Okay, so what we have is this one's the green one because it's alternate, and this is the blue one. So this the 4 is in between blue and red, so it's the 4 corresponds to the 10. Divide 10 by 4 and you get 2.5. The big triangle is 2.5 times bigger than the small triangle. So all we need to do is multiply 6 by 2.5 to find QR. 6 multiplied by 2.5, and that will get you 15. And then to find out what QM is, we got to divide so Q to M means we need to know what P to M is, and to find out what P to M is in between red and green, so red and green is going to be 9 divided by 2.5. Sorry, 9 divided by 2.5. It's going to be 2.5 times smaller, so it's 3.6. Okay. But it's actually Q to M we're looking for, so it's going to be 9 plus 3.6, which is 12.6. Okay, that's that one done. Finally, the last question. Find the volume of the cone. Volume of a cone is 1/3 pi r squared h, which is going to be 1/3 pi times 6 squared times 14. Put it into the calculator. 1/3 pi 6 squared times 14. 168 pi. Now, the shape below is a fulcrum, And what happens is it's made up by taking the cone above and cutting horizontally, removing a height of 7 centimeters. So this is also 7 centimeters. Okay, so your original cone is 14 and you slice it in half. Now you got to remember it's in proportion. So if that's a height of 7, it means this radius will be a height of 3. Sorry, it will be a radius of 3, because if you half the height, you half the radius. Okay, so what we can say here is the radius is 3. So it's going to be, that made it way too easy for you. So what we're going to do is take the volume of the original cone and then take away the volume of the missing cone here. Okay, so the volume of the missing part is going to be 1/3 pi r squared h, which is 1/3 pi times 3 squared times 7. Put that in over 3 pi times 3 squared times 7, which is 21 pi. And then find the ratio of the volume of the Fulcrum to the volume of the original cone. So the volume of the Fulcrum will be 168 pi take away 21 pi, which is 168 take away 21, 147. So it's going to be 147 pi is to 168 pi. Divide both sides by 21, or simply put 147 divided by 168, and you find out the ratio of 7 is to 8. Okay guys, I think that's us. Yep, that's us.